Welcome to the module on flexible payments. Today we will be discussing about the WM plant calibration. What is wet mix macadam? It is a road-based material consisting of a crushed rock or slag, usually pre-mixed with controlled amount of water sufficient for adequate compactions. WM shall consist of laying and compacting clean, crushed gravel, aggregates and granular materials pre-mixed with water to a dense mass on a prepared subgrade, subbase, base or existing pavement as the case may be in accordance with the requirements of MORTH specifications. What is calibration? Calibration is a process to ensure that the measurements being done using a particular gauge is meeting the requirements. In WM plant, the purpose of calibration is to ensure that different proportions of the aggregates are being mixed in the right proportion during the operation of the plant at different capacities. The proportions are pre-decided during the design mix stage of the wet mix macadam in the laboratories. Wet mix macadam WMM mix is prepared in the pug mill of required capacity located near the WM plant. Pug mill is being set to achieve the required gradations in moisture content of the mix as per the mix designs. All the 4 bins being calibrated by setting the gate openings. Once adjusted, the openings needs to be sealed so that it should not be disturbed during operations. Moisture content of the mix should be maintained either 1% or above the ambient temperature to optimum moisture content for compensating the losses of moisture during the transportation. The arrangements of the data required for calibrations are one has to know the plant capacity which he is trying to calibrate. The capacities of the plants are in terms of tonnage per hour, usually call it as TPH, varies from 120 TPH, you have 60 TPH also, then we have 240 TPH, 270 TPH and so on. So depending upon the capacity of the plant, the calibration is being done. Then we need to know the mix proportions as arrived in the laboratory during the design mix stage, like what should be the proportion of 40, 20, 10 and dust in the wet mix macadam during the design mix stage. Then the length of the collection belt or the feeder belt one has to know in order to do the calibration, because the capacity is being termed in terms of tonnage per hour. The belt length will facilitate you to convert the TPH into kgs per meter. Then you should know the individual bins opening type, like whether the openings are being stated in terms of percentage or in terms of the linear measurement, that is millimeters. And then we should have the weighing scale in order to check the weight of the materials being collected from the belt of length say 1 meters. The method of doing a WM plant calibration is, first we need to determine the weight required for each type of aggregate for the working or the running capacity of the plant in tons or kgs per meter or kgs per minute. In this particular example, we have done the calibration in kgs per meter. So what is being done is we have converted the capacity in TPH to kgs per meter. That means a 270 tons capacity plant is converted into 69.44 kgs per meter, or 240 tonnage per hour capacity plant is being converted into 61.73 kgs per meter. Now out of 69.44 kgs per meter total production, the proportion of 40, 20, 10 and dust is being calculated in terms of the percentage in which they have been added during the design mix stage. Like for example, in this particular case, 25% of 40 mm, 25% of 20 mm, 22% of 10 mm and 28% of stone dust, and combined will produce a mix which is suitable for wet mix macadam. Methods of plant calibration, if you see, either you can do with gate openings, like when we do the calibration using a gate opening, the gate openings are generally in terms of percentage or in terms of linear measurement, that is in terms of millimeters. Now, in either cases, by varying the opening size, the discharge of each bin is 40, 20, 10 and dust is being noted down, and then we have to plot a graph between the discharge in y-axis and openings in x-axis. And if it is to be done with the RPM of the feeder belt, then you have to completely open the opening of the discharge, opening of the bin, and then by varying the RPM of the feeder belt, one has to check or record the discharge of each bin, which is 40, 20, 10 and dust. And then you have to again plot a graph between the RPM, taking RPM in the x-axis and the discharge in the y-axis. Now, using the graph, we have to determine the required opening or the RPM for a calculated weight of aggregate, which is forming a part of the wet mix macadam. These things we will be going through in detail when explaining the Excel sheet of how to do the wet mix plant calibration calculations. The layout, if you see, you have the hoppers or the bins for feeding 40, 20, 10 and dust, the 4 types of materials which is being utilized to produce the wet mix macadam. And then you have a mixing unit, which is basically a pug mill type mixture. Then you have a conveyor for collecting the material into the hopper, and then the material is being discharged through the discharge point of the hopper as shown in the photograph. Now, if you see the 4 bins with a closer look, you have 4 bins separated clearly so that the intermixing of the aggregates can be avoided, and each hopper is being designated for single type of aggregate, which is 40, 20, 10 and dust, forming a part of the wet mix macadam. This is the gate lever for gate opening or closing. We have a closer look of gate opening, which is generally shown in terms of percentage in this particular type. Otherwise, you can have the gate openings which are generally in millimeter lengths. So this is your collection belt and the conveyor belt reaching to the mixing units where the material is being mixed, and this is the collecting belt where the material from the hopper is being collected into the collecting belt. Now, when we are doing the calibration of the wet mix plant, the water needs to be calculated and calibrated also in accordingly. Like mixing of water adjustments for free moisture content. Like for example, if you have SSD condition where your 40, 20, 10 and dust are in different ratios and are actually giving you a tonnage per hour, say 50, 23, 24 and 46, and you have a free moisture, then the free moisture is being converted into the weight, which is being required to be deducted from the total moisture of the wet mix macadam, which is generally 6% in this particular case. So 8.64 minus 3.878, between 4.762 metric tons of water is required to be feeded into the wet mix macadam product to make it ready with respect to the OMC requirements. So this is the stage where the water is being mixed into the pug mill so that the material is being mixed properly and being produced with the OMC required. So when we say the calibration part, the water meter reading is being operated for a duration, say 1 minute, and the actual water is being measured, and then you have a graph between the water meter reading and the weight of water being collected with some percentage of error. Now, what is required is for required weight of water in SSD condition is 8.64 tons, Adjusted water is 4.762 tons. So that means you have to operate your plant with the adjusted water, which is 4.972, and the opening meter reading should be around 83 or 84. So this is how the water is collected, and water needs to be adjusted every day with respect to the free water which is being available in the aggregates. So except water, rest of the calibrations can be done one time, but for water, everyday production needs to be checked with the calibration chart. That is why the water meter is being run over a range of readings, and a proper graph is plotted for that particular plant, so that at any point of time, based on the required tonnage per hour of the water, you can check what should be the meter reading which has to be adjusted. This is the condition of the pug mills, where you have a central shaft with a blades on all the faces. The requirement is you need to properly see about the gap between the outer face and the blades of the shaft, so that if the gap is more, then the mixing will not be proper and you will have segregation in the mix. So to start with, the basic calculations which one can do for calibrating the wet mix macadam plant is you need to know the length of the gathering belt. In this particular case, it is 27 meters, which is being measured in the project sites to understand. And then the time taken for one revolution is being noted using a stopwatch, which works out to be 25 seconds in this particular example. Now, to understand the speed of the belt, what is required is length divided by time. Will give you the speed of the belt, which is 1.08 meters per second, and which is equivalent to 3,888 meters per hour. This is the speed of the belt, which is being calculated for a particular type of wet mix plant, which is operational in the project. Now, from the design mix, we know what is the proportion of 40, 20, 10 and stone dust is required to be mixed in order to achieve the required gradations. So, for example, in this particular case, we have identified as 40 mm as 25%, 20 mm as 25%, 10 mm as 22%, and stone dust as 28%. Now, what is required is the capacity of the plant is being identified from the manufacturer's data or any other source which is applicable, and it is understood that the design capacity of the plant is at 270 tons per metric tons. Generally, the plant capacity of the wet mix plant is given in tons per hour, which is in short we'll call it as TPH. So the plant capacity is 270 tons TPH. That means the wet mix plant has the capacity to produce 270 tons of the product that is called wet mix macadam product in 1 hour. Now, if 270 tons per hour is the production capacity, then for each type of aggregate, that is 40, 20, 10 and dust, the quantity of material being produced is 67.5 tons for 48 mm aggregate, 67.5 tons of 20 mm aggregate, 59.54 tons of 10 mm aggregate, and 75.6 tons of stone dust. Now, by varying the capacity of the plant, you can get different tonnages of individual aggregates, provided the percentage combination or the percentage combination of different types of aggregate is kept same. So if you change the percentage combination also, then also these quantities which are shown here in this yellow, or we can mark it as say orange, dark orange line. So this will change with respect to the capacity of with respect to the plant capacity, which is being shown in say blue line, or the purple color which is being shown is the individual aggregates proportions capacity. Now all these things are given in tons per hour. Now what is required is you need to convert these things in kgs per meter length. kgs per meter length. That means if you run the plant by only opening the 40 mm aggregate, you have to after running a plant for say 5 minutes or 10 minutes, you stop the plant and collect the material from the belt which is of length 1 meter. Now the 270 TPH plant is equivalent to 69.44 kgs per meter, and if the capacity is 240, it is being converted into 61.73 kgs per meter, and if the capacity is 210, then the individual aggregates required, or the capacity of the plant in terms of kgs per meter is 54.01. Now what is being done is, theoretically we have divided this 69.44 into different proportions of 40 20 40 20 10 and stone dust based on their percentage combination, which is 25 25 22 and 28%. So this is the capacity of the plant, this is the capacity of each bin aggregates to be produced when running the WM plant, so that if they mixed in these weights, the percentage combination will be meeting the requirements, and as well as the grading requirement will be achieved. Now what is required is, you have the calibration to be done by two methods. One is the gate opening method and then the RPM method. Today we will be discussing the gate opening method. That means the gates are being shown like this, which is having an opening of say 50 25 50 150 100 150 200 and 250. So by changing the opening, each type of aggregate by varying the gate opening, what is being done is, each type of aggregate is being discharged for a fraction of second, and by taking 1 meter length of the sample, you have taken the weight of the sample which is being collected. Like for example, 40 mm aggregate, when the gate opening was 100 mm, the 7.83 kgs of the material is being collected from the 1 meter belt. When the opening is 150 mm, the 11.79 kgs of 40 mm aggregate is collected from the 1 meter belt. When the opening is 200 mm and the plant is run for say 5 minutes or 10 minutes, so that sufficient amount of uniform material is being spread on the belt, then by taking a sample of 1 meter length, 15.8 kgs of the material is being collected from that sample. Similarly, when the opening is 250, 19.54 kgs of the material, that is 40 mm material, is being collected from the bed. Similarly, 20 mm bin, 10 mm bin and dust bins are being considered by opening the gate in a different length, say 50 mm, 100 mm, 150 mm and 200 mm, and the corresponding 1 meter belt sample is being taken and weighed, and the weight which is being collected is being noted in the table. Once this exercise is done, what is being done is, for example, take a case of 40 mm aggregate, a graph is plotted between the gate opening and the weights being collected over a 1 meter length period, 1 meter length belt. So that means in the x-axis, we have taken like for example, in the x-axis we have taken the gate openings in millimeters, and in the y-axis we have taken the weights which is being collected for by taking a sample of 1 meter length of the belt. Now then the graph is plotted for different positions, like for 4 points, which is 100, 150, 200 and 250. Now we know that from the basic calculations that if when the plant is running at a capacity of 270 TPH, that means 69.44 kgs per meter length, then your 40 mm aggregate should discharge at least 17.36 kgs of the material. So from the graph, the 17.36 kg is this line is being drawn, taking a point from the y-axis, and is being drawn on the slope. The point where it cuts the line is being again dropped to the x-axis, and this x-axis value will give you the opening size of the particular bin. That means when the opening is maintained at 221 millimeters, then your plant is running at a capacity of 270 tons per hour. And when the opening is kept at 195, then your plant is running at a 240 TPH, and when the opening is kept at 173, then the plant is running at 210 TPH capacity. And that means at 195, what is being done is at 195 we have considered 15.43 kgs of aggregate is required to be collected at 40 mm. That means in the y-axis we have taken 15.43 point, which is this one, and then drawing a line from 15.43 towards the sloping line and dropping a perpendicular on the axis, you will get the gate opening sizes. And similarly for 210 TPH plant, which is 54.01 kgs per meter capacities, plant running capacities, 13.5 kgs of 40 mm aggregate is required to be collected from a 1 meter sample. That means 13.4 is taken on the y-axis, and then a line parallel to x-axis being drawn when it touches the sloping line, and then from that point you have dropped a perpendicular to the x-axis, and the point at which the x-axis is being intersected is being noted as the opening size of the bin. So at 173 mm opening, your plant will be operating at a 210 TPH for 40 mm aggregate. So in this fashion, for all other aggregates is also being done, like different graphs are being plotted for 20 mm aggregate, 10 mm aggregate and dust, and then corresponding to 20, 10 and dust, the weights required for 250 TPH, which is 17.536, 15.43 for 240 TPH and 13.5 for 210 TPH in case of 20 mm aggregate, or 15.28 for 270 TPH, 13.58 for 240 TPH and 11.88 for 210 TPH in case of 10 mm aggregate, or similarly stone dust aggregate is being considered and being derived from the graph. Once that is done, now what is being observed is then you can make a tabular form for different gate openings of to operate the plant at a different capacities, and when you have a combination of say 40, 20, 10 and dust with a gate opening of say 220, 145, 150 and 165, that means your plant is running at a 270 TPH. Or when the gate opening sizes are 170, 110, 115 and 145, that means your plant is running at a 210 TPH. And if the gate opening is 195, 130, 135 and 155 for 40, 20, 10 and stone dust, then the plant is running at a 240 TPH. This is how the calibration is being done with respect to the gate openings. Similarly, if you want to do it with RPM, then also you have to calibrate the all the 4 bins with respect to the RPM of the feeder belt. Like to get that much amount of 40 mm, 20 mm and 10 mm, like means to get an output of 17.36, what should be the RPM of the feeder belt? To get a 17.36 of 20 mm, what should be the RPM of the feeder belt? And then to get the 15.28 kgs per meter of 10 mm, what should be the RPM of the feeder belt? And then similarly 19.44 kgs per meter length of the belt, what should be the RPM of the feeder belt? Now once you set the RPM of individual bins, then the plant can be operated with a master knob, which can be utilized to increase or decrease the production capacities of the WM plant. So this is the feeder belt, which is a different type of again the plant conditions, where you have this RPM of the feeder belt also, and then the gate openings are also there. So when you do the calibration with respect to RPM, your gate needs to be open for 100%, and then you can check the material like 40, 20, 10 and dust from each hopper for different set of RPM. These are the 40, 20, 10 and dust individual knobs of RPMs are there. Once the individual knobs are adjusted with respect to the designed mix proportions, then these knobs need not be disturbed on the daily production rate. And if you want to increase or decrease the production of the WM plant, this master knob, which is being linked with the individual RPM knobs of 40, 20, 10 and dust is being operated to change or increase or decrease the production of the plant. So to summarize this module, we talked about the definitions of wet mix macadam. We also talked about the calibration requirements and the definition of calibrations, the materials required for wet mix macadam calibrations, what are the conditions under which the wet mix macadam needs to be calibrated, or either it can be calibrated using the gate openings or it can be calibrated using the RPM of the feeder belts. Under both the cases, once the calibration is done and being set, it need not be disturbed, so that over a period of time the productions can be increased or decreased depending upon the changes required to be conducted on the master knobs. Thank you.